Okay, so this video lesson is going to be about trig ratios and right triangles. A ratio represents the sides of a triangle with respect to an angle. So remember, an angle is called theta. This little circle with a line through it. And then if I'm talking about this angle right here, my sides of my triangle are going to be opposite my angle. Opposite angle you can always draw from the corner of that triangle to the opposite side. My adjacent side, remember, means what's next to my angle, touching the angle. And the hypotenuse is always opposite the right angle. So the right angle kind of points to the hypotenuse of the triangle. Now you need to know the 6 basic trig functions. And those are sine, cosine, and tangent. We know sine is opposite over hypotenuse. Cosine is adjacent over the hypotenuse. And tangent is opposite over adjacent. And you can remember that from the SOHCAHTOA. Whoops. Page. And the one other important thing about tangent, and it's also equal to sine over cosine when it, the time it's important is when we're simplifying trig expressions. We'll have to simplify tangent into sine over cosine, both of theta. The other 3 trig functions, the reciprocal functions that we need to remember, are cosecant is a reciprocal of sine. So it's the same thing as 1 over sine of theta. Cosine is a reciprocal of secant. So it's 1 over cosine, when I type it in my calculator, of theta. And cotangent is a reciprocal of tangent. So 1 over tangent in my calculator. But if I know sine, cosine, and tangent in respects to my triangle up here, for opposite, adjacent, and hypotenuse sides of them, I know cosecant is a reciprocal of sine. Reciprocal means I flip it. So I want to flip these two. So if I flip hypotenuse, or opposite and hypotenuse, I'm going to have hypotenuse over opposite. For secant, which goes with cosine, if I flip adjacent over hypotenuse, I'm going to have hypotenuse over adjacent. And then if I flip tangent, opposite over adjacent, I'm going to get adjacent over opposite. So as long as you know the SOHCAHTOA, you can figure out cosecant, secant, and cotangent. The only way I can tell you to remember what reciprocal function goes with what basic trig function is S goes with C. Because a lot of people like to confuse sine and secant because they both start with S. But S is paired with C. So sine is paired with cosecant. Cosine, a C is paired with an S, which is secant. So S goes with C. That's the best way I could tell you to remember it. When you know a ratio, you can use the ratio to find the angle. Or if you know the sides, you can find out the ratio and find the angle. That's using the inverse functions. The inverse trig functions are a button on your calculator. And if I know the two sides, the opposite and the hypotenuse, of some angle, but I don't know the angle, what I would do is do the inverse function. So I'd take the inverse of my ratio, and that will give me my angle, which is represented by theta. And that works for any trig function. I could do cosine inverse, since it's the inverse trig function, that's what you call it, cosine inverse of the ratio which is adjacent over hypotenuse. And that will give me the angle for those two sides that represent that angle. I could do the tangent inverse of my ratio, which would be opposite over adjacent, and that will give me that angle that's represented by those two sides of the triangle. And it also works for the reciprocal trig functions. So we're going to do a couple examples. Okay, so I'm going to do this example with the multiple parts. First, I want to determine the ratio of all 6 of these trig functions: sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. When it says find the ratio, all you're doing is looking for that fraction that represents the sides of the triangle. And then you have to simplify if you need to simplify. The last thing I'm going to do is find the measure of angle A. So find out whatever this angle is using one of my inverse functions. So whenever you're finding the ratio, you're looking for the sides of the triangle. Whenever you're trying to find the angle, that's when you have to use the inverse function. So ratio, you just use the trig functions because you're looking for the sides of the triangle. When you're trying to find the angle, that's when you have to use the ratio or the inverse function. So if I want sine, I know sine is opposite over hypotenuse. So looking at this triangle, my opposite side is going to be 4. So I have 4. And my hypotenuse, opposite the right angle, which should be labeled, is 2 radical 13, or 2 square root of 13. So I have 2 square root of 13. You cannot have radicals in the denominator, so I need to rationalize my denominator. And I can also simplify my 4 and my 2 before I do that, because 4 divided by 2 will reduce down to 2 over the square root of 13. So now I can rationalize my denominator by getting rid of my square root of 13. So to do that, I need to multiply by the square root of 13 over the square root of 13. The reason you have to do the top and the bottom by the denominator is because you need to multiply by 1, because the square root of 13 over the square root of 13 is just 1. So if you're multiplying by 1, you're not changing the value of this fraction, you're just making it look different. So 2 times the square root of 13 is just 2 square root of 13, because you can't multiply radicals in whole numbers. And the square root of 13 and the square root of 13, you can multiply it out and get the square root of 169. But if you take the square root of 169, you end up with 13. Whenever you multiply a radical by itself, you're kind of squaring it, and square and a square root cancels each other. So that's why it just ends up being whatever's underneath the radical. So the next one, cosine of theta. So cosine is adjacent over hypotenuse. So if I'm looking at the adjacent side of theta, adjacent would be next to, so that'd be 6. And then the hypotenuse across right angle is 2 radical 13. Or 2 square root of 13. You could say it either way. So, like before, my 6 and my 2 is going to cancel. So I get 3 over radical 13. And then I have to rationalize my denominator. So radical 13 divided by radical 13. And I get 3 times radical 13 is 3 radical 13. And radical 13 times radical 13 just ends up being 13. And 3 and 13 don't reduce anymore, so that's your answer. Tangent of theta. Tangent's opposite over adjacent. So if I'm looking at the opposite side of theta, that would be 4. My adjacent side next to my angle is 6. So 4 over 6 reduces to 2/3. So cosecant. Cosecant, you need to remember, is a reciprocal function for sine. The only way I could tell you to remember it, because a lot of people think S goes with S for sine and secant, but it does not. Sine is cosecant. They're the pair. Is a reciprocal function. S goes with C. So cosine and secant go together because S goes with C again. C and S, S and C are paired up. So if I know cosecant's the reciprocal of sine, I know cosecant has to be hypotenuse over opposite. So if I'm looking at my hypotenuse side for the triangle, I have 2 square root of 13 divided by my opposite side is 4. And then I could just reduce my 2 and my 4, so it becomes radical 13 over 2. So secant is a reciprocal of cosine. So if I know cosine is adjacent over hypotenuse, I know secant is hypotenuse over adjacent. So my hypotenuse is again 2 radical 13 divided by my adjacent side, which is next to my ankle, touching my angle, is 6. If I reduce those two, 2 and 6 is going to reduce. And that will become square root of 13 divided by 3. And then my cotangent's the reciprocal to tangent. So cotangent is adjacent over opposite. And again, my adjacent side is 6, which is next to my angle. My opposite side is 4, so that reduces to 3 over 2. So that's finding the ratios. If I want to find the angle, I can use any one of my trig functions, sine, cosine, tangent, cosecant, secant, or cotangent, and use the inverse function of it. Since I know all of them, since I know all the sides of the triangle, So I want to find the angle value of A. So if I use sine, I would do sine inverse, because I'm trying to find my angle, of my ratio that I found out it to be. And it's not going to be an exact value unless you have nice sides of the triangle. Since we have a radical, it's not going to turn out to be a pretty angle. So I have sine inverse of my ratio. So if I write in my ratio, I figured out my ratio to be for sine 2 square root of 13 over 13. So that's what I'm going to write in. So 2 square root of 13 divided by 13. And I want to type that into my calculator. And I'll show you a picture of it. Okay, so if I use this, I'm typing in sine inverse. And I get that by second, and then sine will give me my sine inverse. And then I need to type in 2 square root of 13 divided by 13. But I need to make sure my parentheses are correct. So 2 square root of 13, and I need to close that parenthesis for 13, divided by 13. And I need to make sure that everything that I want to take the inverse of is all inside parentheses. So I'm starting before 2, and I'm ending after dividing by 13. And since you're trying to find an angle, you need to make sure your mode is in degrees. If it's in radians, it's going to give you a decimal, and it's going to be wrong. So I end up getting, we'll round to the nearest tenth. So I get 33.7 degrees is my answer. And if I check that using cosine, I'll show you the calculator quickly. If I use the cosine inverse function of that ratio, which we found out to be 3 radical 13 divided by 13, if I type that in my calculator, I end up getting the same angle. So it doesn't matter which ratio you choose to use, as long as you know your ratio is correct in reference to the size of the triangle. So you'll do a couple on your own. Okay, so I want you to do 2 examples on your own. Using this first triangle, 3, 6, and the hypotenuse is 3 radical 5. I want you to find the sine of B, talking about this angle, cosine of B, tangent of B, cosecant of B, secant of B, cotangent of B, and then the measure of angle B, so find out what that measure is. And then sine of A using this triangle, cosine of A, tangent of A, cosecant of A, secant of A, cotangent of A, and then the measure of angle A, so talking about this angle. And then we'll talk about them in class.